curl the curl of a vector point function capital F is defined as curl vector F equal to del cross vector F, which is equal to I del upon del x plus j del upon del y plus k del upon del z cross f1 I plus f2 j plus f3 k, which is equal to determinant of I del upon del x f1 j del upon del y f2 k del upon del z f3, which is equal to I del f3 upon del y minus del f2 upon del z minus j del f3 upon del x minus del f1 upon del z plus k del f2 upon del x2 minus del f1 upon del y. Okay. So the value of curl vector f is a vector quantity. Curl vector f is a vector quantity. Okay. Physical meaning of the curl. Okay, as we know that V equal to omega into R, where omega is our angular velocity and vector v is linear velocity and vector r is the position vector of a point on the rotating body. Okay, so curl v equal to del cross vector v, which is equal to del cross omega cross vector r. So del cross omega vector is omega 1i plus omega 2j plus omega 3k. Okay, so omega 1i plus omega 2j plus omega 3k cross vector r. The vector r equal to xi plus yj plus zk. So xi plus yj plus zk. Okay, so we can write as I j k and omega 1 omega 2 omega 3 x y z. So del cos omega 2 z minus omega 3 y of I minus omega 1 z minus omega 3 x of j plus omega 1 y minus omega 2 x of k. Okay, now the value of del is I del y del x plus j del y plus k del y del z cos omega 2 z minus omega 3 y I omega 1 z minus omega 3 x j plus omega 1 y minus omega 2 x of k. So we can write as determinant of I del upon del x omega 2 z minus omega 3 y j del upon del y omega 3 x minus omega 1 z k del upon del z omega 1 minus omega 2 x. Okay, so omega 1 plus omega 2 of I minus omega 2 minus omega 2 of j omega 1 and plus omega 3 plus omega 3 of k, which is equal to 2 times omega 1 I omega 2 j omega 3 k, which is equal to 2 times of omega vector. So curl of vector v is equal to 2 omega. Okay, which is shows that the curl of a vector field is connected with rotational property of a vector field. Okay, if curl of f equal to 0, that means the field f is irrotational. Okay, next question is find the divergence and curl of vector v is equal to x y z of I 3x square y of j plus x z square minus y square z of k at a point 2 comma minus 1 comma 1. So we know that divergence v is equal to del phi. So here vector v is equal to x y z of I plus 3x square y of j plus zx square minus y square z of k. So divergence vector v is equal to del v. That means del upon del x y z plus del upon del y 3x square y plus del upon del z x z square minus y square z. So y z plus 3x square plus 2x z minus y square. Okay, at the point of 2 comma minus 1 comma 1, the value of x is 2, y is minus 1 and z is 1. Then minus 1 plus 12 plus 4 minus 1, that is 14. It is at a point of 2 comma minus 1 1. Okay, now for curl v, we can write as I del y del x and x y z, j del y 3x square y and k del y del z x z square minus y square z. Minus 2yz I minus z square minus xy j plus 6xy minus xz k. Okay, so minus 2yz I plus xy minus z square j plus 6xy minus xz of k. Curl at 2 comma minus 1 comma 1, then the value of x put is 2, y put is minus 1 and z is 1. Then we get this one. That means 2I minus 3j minus 14k. This is the value of curl v at a point 2 comma minus 1 comma 1. Okay, I repeat this question. Find the divergence and curl of vector v, this one, at the point of 2 comma minus 1 comma 1. So here we given vector v is x y z of I plus 3x square y of j plus x z square minus y square z of k. For divergence we have this formula, and the value of z is I del y del x plus j del y del y plus k del y del z, and the vector v is x y z of I 3x square y of j plus x z square minus y square z of k. So we know that the value of I dot I is 1, j dot j is 1, and k dot k is 1, and others values are 0. So we get del y del x of only x y z plus del y del y 3x square y and plus del y del z is x z square minus y square z. Here we differentiate partially with respect to x, then we get yz. The value of x is 1. Here we differentiate with respect to y partially, then we get 3x square y, and here we differentiate z. We differentiate with respect to z partially, then we get x 2z minus y square, and the value of x comma y comma z is given as 2 comma minus 1 comma 1. So value of x is 2, put here and here. The value of y is minus 1, put here and here. The value of z is 1, put here and here, and calculate these terms. So 14 at a point of this term. ठीक है. For curl vector v is determinant of I j k, coefficient of I del y del x, coefficient of j del y del y, and coefficient of k is del y del z. And in the form of vector v, the coefficient of I is x y z, put here. Coefficient of j 3x square y, put here, and coefficient of k x z square minus y square z, put here. And solving the determinants, I this into this minus this into this minus j this into this minus this into this plus k this into this minus this into this. Then we get this term, taking minus sign, second term this term, and the curl vector v at a point 2 comma minus 1 comma 1. So the value of x is 2, put here, here and here. The value of y is minus 1, put here, here, this. The value of z is 1, put z, this one and this one, and calculate them. Then we get the value of curl v at a point 2 comma minus 1 comma 1, this one. Next question is, prove that y square minus z square plus 3yz minus 2x of I plus 3xz plus 2xy of j plus 3xy minus 2xz plus 2z of k is both solenoidal and irrotational. And irrotational. Solution. Let vector f is y square minus z square plus 3yz minus 2x of I, 3xz plus 2xy of j, 3xy minus 2xz plus 2z of k. For solenoidal vector, we have to prove that del cross f is equal to 0. So now del cross f, del means I del upon del x plus j del upon del y plus k del upon del z dot f. F means these terms, y square minus z square plus 3yz minus 2x I, 3xz plus 2xy j, 3xy minus 2xz plus 2z of k. So I dot I is 1, j dot j1 and k dot k1. So this differentiate this, here only 2x, that means minus 2 plus j dot j, del y multiplied by this term. Here only y function is this one, so here remaining 2x. यहाँ पे माइनस 2 जेड में 2x प्लस 2, so which is equal to 0. That means the vector f is solenoidal. Thus vector f is solenoidal. Okay. For a rotational vector, we have to prove that curl f is equal to 0. So curl f, which is I del y del x and the coefficient of I, that means this term, y square minus z square plus 3yz minus 2x, j del y, coefficient of y, 3xz plus 2xy, k del y del z, that means this term, 3xy minus 2xz plus 2z. Expanding the determinant, then we get I times this minus this, I times del y 3xy minus 2xz plus 2z, this minus this, I this minus this, and a will del y del z, 3xz plus 2xy. Okay, minus j times, j means this term, del y del x 3xy minus 2xz plus 2z j times minus del y del z and y square minus z square plus 3yz minus 2x plus k means this one, del y del x into this term, del y del x into 3xz plus 2xy minus del y y square minus z square plus 3yz minus 2x. Okay, now differentiate with respect to y partially. 3x only. Okay, 3x plus 2y. No, only y में. Okay, 3x minus z, it means 3x minus j, x में 3y minus 2z minus z में minus 2z which is minus plus and minus 3y plus k vector into k, x में 3z plus 2y, here minus 2y and minus 3z. So 3x cancel out, 3y 2z cancel out. Okay, and 3y 3z cancel out, 2y cancel out. So 0I minus 0j plus 0k, that means 0 vector. So finally vector f is both solenoidal and irrotational. Okay, now repeat the question is again, prove that this vector is both solenoidal and irrotational. Here note down the vectors, this one. For solenoidal vector, we know that the formula of del dot f is equal to 0. Now we have to prove del dot f is equal to 0. So del dot f means del means this term and vector f is given this term, I dot I, j dot j and k dot k. So I dot I means differentiate only this term, j dot j means differentiate with respect to y and k dot k means differentiate with respect to z, and solve them, then which is equal to 0. That means the vector f is solenoidal. Okay, for irrotational we have to prove the curl f 0. For curl f we know that the determinant of I, j, k, coefficient of del x, del upon del x, del upon del y, del upon z, and here the coefficient of I, j, k vectors, this one, I coefficient, j coefficient and k coefficient, and expand the determinants according the properties. Then we get I this into this minus this into this, minus j this into this minus this into this plus k this into this minus this into this and expand. Here differentiate partially with respect to x, here differentiate partially with respect to z, and here differentiate with respect to x, and here differentiate with respect to z, and here differentiate with respect to x and y. Okay, so we get y means 3x, others 0, z means 3x and others 0, so 3x 3x cancel out. Similarly, in the coefficient of j, 3y cancel out and 2z cancel out. Similarly, in the coefficient of k is again differentiate x means 3z and this is 0. Differentiate with respect to y means here 2y and here 3z. Both terms are negative, so negative terms, and again cancel out. So 0i plus 0j plus 0k, that means a 0 vector. That means the value of the curl f is 0. So the vector is both solenoidal and rotational vector. Okay, it is the important topic for proving regarding solenoidal and rotational vector.